They call it the king of fruits, and across Southeast Asia, it wears that crown proudly. To its fans, it's a creamy, complex, and divine culinary experience, with a flavor compared to rich custard, almonds, cheesecake, and even a hint of sherry. To everyone else, it's a biological weapon, a fruit so pungent it's banned from subways, hotels, and airports across an entire continent. Its infamous smell has been described as a lovely cocktail of rotting onions, old gym socks, and turpentine. Yeah, love it or hate it, the durian gets your attention. But believe it or not, the real story here isn't its polarizing smell or its heavenly taste. The real story starts after you're done eating. This is the part of the durian we never talk about, the part we just throw away. The spiky, tough, and incredibly heavy husk. The edible, creamy pulp that people love can be as little as 15 or 30% of the fruit's total weight. The rest, a massive 70–85%, is the shell and the seeds. We're talking about millions of tons of shells piling up in landfills every single year, releasing nasty odors and planet-warming methane gas. It's a stinky, spiky, and genuinely huge environmental problem. But what if this trash wasn't trash? What if, hidden inside this fortress of thorns, was a blueprint for a cleaner, greener future? What if we could turn one of the world's most problematic waste products into clean energy, powerful medicines, and next-generation materials? A handful of visionary scientists are doing just that. They're turning this landfill nightmare into a treasure. The question isn't just why, it's how. Chapter 1. The King's Costly Crown. To really get the miracle of this transformation, you first have to understand the sheer scale of the problem. The durian is more than a fruit. It's a cultural obsession and an economic giant. The global durian market was valued at over $17 billion in 2024 and is projected to race past $25 billion by 2031, thanks to a ravenous demand, especially from China. Countries like Thailand, Malaysia, and Vietnam are the titans of this industry, pumping out millions of tons of this fruit every year. And with every ton of fruit, you get a ton of waste. The edible part is a surprisingly small fraction of the whole thing. The rest, that massive, spiky shell and the large seeds, is just discarded. And this isn't like an apple core. Durian shells are heavy, woody, and covered in sharp spikes. They don't break down easily. In the past, the options for getting rid of them were grim. Mountains of these husks were either trucked to landfills or just openly burned. Both are environmental disasters. In a landfill, organic waste like durian shells rots without oxygen. That process releases a flood of methane, a greenhouse gas that's over 28 times more potent at trapping heat than carbon dioxide over a 100-year period. As the shells rot, they also create a toxic slime called leachate, which can contaminate soil and groundwater, all while releasing that infamous durian stink. Open burning is no better, spewing thick, toxic smoke into the air. This is the durian's paradox. A fruit celebrated as a king, leaving behind a crown of thorns for the environment. For decades, this was just seen as the cost of doing business. The shells were a worthless, hazardous byproduct, an endpoint. But as the world started scrambling for answers to our waste and climate crises, a new generation of thinkers looked at this spiky problem and saw something different. They didn't see an end point. They saw a starting point. They didn't see waste. They saw a resource. They looked at the tough, fibrous structure of the durian shell and asked a game-changing question: what is this stuff actually made of? And what can it do? Chapter 2. The what-if moment, a scientific quest. That shift from seeing a problem to seeing potential, that's where all great innovations are born. For the durian shell, the what-if moment came from scientists who understood a basic truth. In nature, There's no such thing as waste. Every output is just an input for something else. A durian shell, perfected over millions of years of evolution, had to be more than just a spiky shipping container. Its incredible toughness was a clue. Chemically, a durian shell is a goldmine of organic compounds. It's mostly made of cellulose, hemicellulose, and lignin, the same stuff that gives wood its strength. Cellulose is the most abundant organic polymer on the planet, basically long chains of sugar that give plants their structure. Lignin is the glue that holds it all together, making the shell tough and resistant to rot. This exact composition is what makes durian shells so promising. They are a dense, predictable, and incredibly abundant source of what's called lignocellulosic biomass. We can't digest it, but it's the perfect raw material for all sorts of advanced industrial processes. Scientists realized if they could just find the right keys to unlock these complex polymers, they could break them down and rebuild them into something valuable. This sparked a global quest, with research labs and universities, especially in Southeast Asia, where the shells are everywhere, racing to crack the code. They didn't just imagine one solution, they saw a whole portfolio of them. They mapped it all out. The shell's high carbon content made it a perfect candidate for a process called pyrolysis, which could turn it into a powerful fuel and soil conditioner called biochar. The rich mineral content, especially potassium, hinted at the potential for creating cheap but powerful chemical catalysts. And the long, strong cellulose fibers themselves could be pulled out and purified to make a new generation of green biomaterials, potentially replacing plastics. This was the roadmap, the challenge, taking it from a lab bench to an industrial scale. The mission was on: build a factory of the future that could take in millions of tons of stinky, spiky garbage and spit out a stream of clean, green, and valuable products. Chapter 3. The Factory of the Future. The process begins. This is where the transformation from a roadside fruit stall to a high-tech superfuel begins, a modern biorefinery. And the first step in any refining process is making sure your raw material is pure. Trucks loaded with durian shells arrive daily. But they don't just get dumped in a heap. The first step is intelligent sorting. Picture a wide conveyor belt, a river of spiky green and brown shells. As they move, they pass under high-speed cameras and advanced sensors. In milliseconds, an AI system, trained on hundreds of thousands of images, analyzes every single shell. It instantly spots anything that isn't supposed to be there: a stray piece of plastic, a rock, a moldy fragment. When it detects a contaminant, a perfectly aimed puff of compressed air blasts the unwanted item right off the line. This AI-powered quality control is relentless, ensuring only the purest material moves forward. It has to be, because the purity of the final product depends entirely on the cleanliness of what you start with. Once sorted, the shells are tumbled through massive drums for an industrial-strength wash. High-pressure water jets blast away any remaining dirt and debris. This stage also tackles the durian's most famous feature: the smell. Special, eco-friendly deodorizing agents neutralize the sulfur compounds that cause that pungent aroma. This not only makes the factory a better place to work, but it's critical for creating clean, odor-free products. Now clean, the shells are ready for deconstruction. First up, the spikes. They're fed into a machine with hardened steel blades that shear off the sharp thorns. Now much safer to handle, they move to the main event, the crushers. These aren't your kitchen grinders. We're talking about heavy-duty industrial machinery built to pulverize tough, woody husks. With immense force, the shells are shredded and crushed, going from bulky domes to small, manageable fragments. These fragments, however, are still full of moisture. For the next steps, moisture is the enemy. It can mess with chemical reactions and kill efficiency. So the crushed pieces are sent into a multi-layer drying system. They travel through chambers where hot, dry air circulates with precise temperature and humidity control, carefully reducing the moisture content to less than 10%. This isn't just about drying. It's a calibrated step to prepare the feedstock for its ultimate destiny. The journey is just beginning, but what was once worthless trash is already well on its way to becoming a high-value, engineered material. Chapter 4. Pathway 1. The biochar. Miracle. With the shells now cleaned, crushed and perfectly dried, they arrive at a fork in the road. Here, the stream of biomass splits, heading down different paths to be reborn as entirely different products. The first path leads to a process humans have used for millennia, now perfected with modern science: pyrolysis. Pyrolysis is basically heating organic material in a low oxygen or no oxygen environment. Think of it as a giant, high-tech pressure cooker. By heating the durian shell fragments without enough oxygen to let them burn, you don't get fire and ash. Instead, the complex organic polymers, the cellulose and lignin, start to break down into simpler, more valuable stuff. As the temperature in the pyrolysis reactor climbs to around 150–190 degrees Celsius, moisture and other volatile compounds vaporize. This vapor is collected and condensed into a dark, amber liquid called wood vinegar, or pyrrolenious acid. For centuries, this was just a forgotten byproduct of making charcoal, but today, we know it's valuable. Wood vinegar is a powerhouse in agriculture. When diluted, it acts as a natural, non-toxic pesticide and fungicide, protecting crops without harsh chemicals. It can also improve soil quality and boost plant growth. It's even used in livestock farming as a feed supplement and a natural deodorizer for barns. What was once just smoke is now a key product in a circular economy. But the main event happens as the temperature soars towards 500 degrees Celsius. Deprived of oxygen, the shell material doesn't burn, its chemical bonds just shatter. Combustible gases, known as syngas, are released. In modern plants, this gas isn't wasted. It's captured and looped back to help power the reactor, making the whole process more energy efficient. What's left behind is a solid, black, incredibly lightweight material. It looks like charcoal, but it's so much more. This is biochar, the stable, carbon skeleton of the original durian shell. And the biochar from durian shells is exceptionally high quality, with some studies showing a fixed carbon content of over 70%. This black gold is packed with stored energy. Research has demonstrated that durian shell biochar has an impressive heating value, in some cases over 26 mJ, or more than 6,000 kcal, making it a potent energy source. To harness that energy, the raw biochar is ground into a fine powder, mixed with a natural binder, and compressed into uniform briquettes. The result is a smokeless, high-energy charcoal fuel. Unlike traditional charcoal, these biochar briquettes burn cleanly and consistently, making them a fantastic, sustainable alternative for cooking and heating. Through the elegant process of pyrolysis, a stinky fruit shell is forged into two valuable products: a liquid elixir for farms and a solid superfuel for clean energy. Chapter 5. Pathway 2. The Catalyst Revolution. While one stream of crushed durian shell is being transformed by fire, another is diverted down a different path, one rooted in the shell's natural chemistry. This path turns the humble husk into a high-performance engine for chemical reactions. A catalyst. In chemistry, a catalyst is something that speeds up a reaction without being used up. The most famous catalysts, like platinum, are incredibly effective but also ridiculously expensive. The holy grail of green chemistry is finding catalysts that are cheap, abundant, and environmentally friendly. And, shockingly, the durian shell fits the bill. The first goal here is to revolutionize the production of biodiesel. Biodiesel is a renewable fuel made from vegetable oils, but converting that oil requires a strong catalyst, usually a corrosive chemical that becomes hazardous waste. Scientists discovered the durian shell offered a much smarter, greener way. The process is called calcination. The crushed shells are heated in a furnace to around 350 degrees Celsius. The goal isn't to create biochar, but to activate specific minerals naturally found in the shell, especially potassium compounds. The heat transforms these compounds on the surface of the shell fragments, turning them into highly active catalytic sites. The result is a simple, brownish powder that's actually a powerful, solid catalyst. In the factory, this activated shell powder is mixed with palm oil and methanol. It efficiently drives the reaction to convert the oil into high-quality biodiesel, achieving yields of over 94%. And the best part, because the catalyst is a solid, it can be easily filtered out, washed, and reused multiple times. A waste product is now at the heart of making a renewable fuel, slashing costs and pollution. As incredible as that is, it's just the start. The second part of this journey takes us to the cutting edge of energy tech. Fuel cells. Fuel cells create electricity directly from a fuel like hydrogen, with only water as a byproduct. One of their biggest hurdles is the catalyst needed for a key step called the oxygen reduction reaction, or ORR. For decades, the only thing good enough for the job was platinum. The insane cost of platinum is a major reason we don't see fuel cells everywhere. This is where the durian shell makes its most futuristic contribution. Scientists have developed a method to upcycle durian shell biomass into a world-class ORR catalyst that can go toe-to-toe with platinum. The process is more complex, involving pyrolyzing the shell biomass with other simple compounds. During this process, carbon, nitrogen, and iron atoms arrange themselves on the durian's carbon structure, creating sophisticated high-surface area catalysts dotted with what are called iron-nitrogen-carbon (VNC) active sites. When tested in the lab, the performance is astounding. It demonstrates exceptional efficiency, achieving key performance metrics that put it in the elite class of catalysts, rivaling commercial platinum versions. Plus, it's more stable and isn't poisoned by methanol, a problem that plagues platinum. This is a massive breakthrough. It points to a future where the expensive platinum in a fuel cell could be replaced by a material that starts its life as stinky garbage. It could slash the cost of fuel cells for cars, power plants, and electronics. On this path, the durian shell has been transformed into a piece of nanotechnology, an engine for the clean energy revolution. Chapter 6. Pathway 3. The building blocks of a green future. While fire and chemistry forge durian shells into energy and catalysts, the third and final pathway in our biorefinery takes a more direct approach. It doesn't try to change the shell's core components, but to liberate them in their purest form. This path is all about extracting one of nature's most essential building blocks, cellulose. The durian shell, as we know, is a fortress of lignocellulosic material, strong cellulose fibers held together by a lignin glue. This third process is a kind of molecular deconstruction designed to carefully separate those components. After drying, shell fragments are sent for mechanical fiber separation. Through milling and refining, the material is processed to break the lignin's grip and free the cellulose fibers. This is followed by a purification and bleaching process using green chemistry to ensure the whole thing is sustainable. What comes out at the end is a soft, white, incredibly pure cellulose powder. This is the fibrous skeleton of the durian shell, now isolated and ready to be used in a nearly limitless number of ways. For a world drowning in plastic, this cellulose powder is a lifeline. It can be used to create biodegradable materials molded into packaging, containers, and disposable cutlery that, unlike plastic, will safely break down into harmless organic matter. But it goes even further. The extracted cellulose can reinforce other materials, making them stronger and lighter. It's a key ingredient in paper, cardboard, textiles, and even cosmetics and foods where it's used as a thickener. Maybe one of the most exciting frontiers for this durian-derived cellulose is in medicine. Scientists have shown this type of cellulose powder can be turned into soft, flexible hydrogels. Researchers are pioneering the use of these gels, which can hold huge amounts of water to create advanced wound dressings. They keep a wound moist, cool, and protected, which can dramatically speed up healing. And since it's made from a natural material, the risk of an allergic reaction is minimal. On this pathway, the durian shell is dismantled to provide the renewable building blocks for a new green economy, one with less plastic, more sustainable materials, and even better medical treatments. Chapter 7. The Treasure Trove, a World of Applications. So, we've walked through the factory of the future and seen the 3 miraculous pathways that turn a stinky waste into a portfolio of high-value products. Now let's step back and look at the incredible treasure trove we've created. First, biochar, the black gold. Its most vital role is in fighting climate change. When a durian shell rots in a landfill, its carbon turns into methane. When it's made into biochar and added to soil, that carbon gets locked away for hundreds, maybe thousands of years. It's carbon sequestration. Every ton of biochar is carbon that isn't warming our planet. For our food systems, biochar is a miracle worker. Its incredibly porous structure acts like a super sponge in the soil. Studies show durian shell biochar has a massive surface area, allowing it to hold on to water and nutrients, making crops more resilient to drought. It boosts soil health and leads to higher crop yields with less need for chemical fertilizers. And for our water, that same porous structure is a natural filter, trapping pollutants like heavy metals, pesticides, and industrial dyes. It's a low-cost, high-efficiency way to clean contaminated water born from agricultural waste. Next, the catalysts. They represent a huge shift in green chemistry. The biodiesel catalyst makes renewable fuel production cheaper and cleaner. But the oxygen reduction reaction, catalyst for fuel cells, is the real game changer. By creating a catalyst from cheap, abundant durian shells that rivals the performance of rare, expensive platinum, this technology could shatter the primary cost barrier to a hydrogen fuel cell economy. Imagine a world where the power source for clean cars is made possible by something we used to throw away. Finally, the purified cellulose powder is our ticket to a future beyond plastic. It provides the raw, renewable material for a new generation of biodegradable products. We can imagine a true circular economy where waste from growing food is used to create the packaging for that same food, which then biodegrades back into the earth. It closes the loop. And the potential for advanced hydrogel bandages shows that the applications stretch from the everyday to the extraordinary. Together, these pathways create a system where nothing is wasted. A problem is turned into a dozen solutions. An environmental liability becomes an economic asset, creating green jobs and driving innovation. This isn't just recycling. It's a complete reimagining of what's possible. The story of the durian shell is more than just a tale of clever science. It's a perfect symbol for the future of sustainability. For too long, we've lived in a linear world. Take, make, dispose. We pull resources from the earth, make stuff, and then throw it away, creating mountains of waste. The durian shell miracle shows us a different way forward, the path of a circular economy. It's a world where the very idea of waste becomes obsolete. In its place, we have resources. The smelly husk behind a fruit stand is no longer an ending. It's the beginning of several new stories. It's the beginning of cleaner energy, healthier farms, purer water, and a world less hooked on fossil fuels and plastics. What happened here was a shift in perspective. Scientists and engineers refused to accept a problem as permanent. They looked at a spiky piece of garbage and, with curiosity and creativity, they found the treasure inside. They took it apart, understood it, and rebuilt it into something that serves both people and the planet. This mindset is the real super fuel. This approach can be applied to almost any waste stream you can think of, from coffee grounds and rice husks to construction debris. The solutions are out there, waiting in the most unlikely of places. The durian shell teaches us a powerful lesson. In the fight for a sustainable future, we have to be creative enough to believe that our biggest problems might just be the source of our most brilliant solutions. The answers aren't always in discovering something new, but in seeing the old and discarded in a completely new light. If you were amazed by the secret power hidden inside this stinky fruit, be sure to hit that subscribe button and ring the bell so you don't miss our next dive into the incredible science that is reshaping our world. We believe solutions are everywhere. What other common waste product do you think holds a hidden treasure? Let us know your ideas in the comments below. Thanks for watching.